Hello, welcome to a new episode on using ConceptBase. The topic of this episode is a formulation of some simple queries. My name is Manfred Josselt, and I just start with this little example. So this is a database of flight connections. Cities have connections to other cities. The relation between cities is called contour, connection to. And well, here's the city of Rome having connection flights to a couple of cities here. Um, this is just a simple example. There are other more sophisticated examples where you still have some relation like connection to, which you would like to follow maybe over several steps. So we'll show how to do that here. So let's start with our first query. That is, we are interested in all the cities that have at least one connection to another city, C. So city with connection is a query class, so it is also a class that has instances. It's a subclass of all cities, so only a subset of all cities fulfills the membership constraint. So the constraint says there must be another city C such that this city that stands for yeah, any city that is in this range of all cities has a connection to this other city C. Could also be a self connection, but the database doesn't have such cyclic flights from city to itself. Um, so when we ask this query, we well, if we first can tell that it's part of the database, then when we ask that, we get a long list of cities. So it seems that all the cities have at least one connection. So it may be more interesting to see the cities that don't have a connection to another city, and that's our second example. So again, we first tell this definition to the database, then it's a class like other classes. The only difference is that the instances are computed by this membership constraint. So all cities like this that fulfill this constraint are in this class. The instantiation to this class is derived from this membership constraint. So let's tell it and then ask it, and we only have four cities here that don't have a connection to another city in the database. Maybe the database is incomplete. Good, that are the first queries. Let's continue with slightly more complicated example. Give me all cities that have a connection to two important cities, London and Paris, yeah, which we decided to designate as hub cities. So cities that have a direct connection to these hub cities are called city to hub. Let's tell it again and ask. Yeah, in this database we have just 6 cities that have a connection to London and Paris. We can also have the reverse relation. So city from hub. So there is a direct connection from either London or Paris to our city. We can reach it from a hub. Let's tell it and ask it. And here we have these cities. Yeah. Now Uh, we might be interested in cities that are both having direct flights to a hub city, London and Paris, and from a hub city like London and Paris. And let's call that a hub candidate. So we the the superclass of this query class is both city to hub and city from hub. And in the logic of concept basis is interpreted as a conjunction. It must be both a city to hub and a city from hub. Let's tell it. Okay, that's a mistake. There was a typo, capital character. So now it should work. And now we only have two cities that are hub candidates. So they have both a direct flight to London and Paris and from London and Paris, these two cities in this database. Good. That's a hub candidate. Now, the next query is about reachability. We are interested in those cities that are reachable from Frankfurt. So this relation transcontour shall be the transitive closure of this. Yeah, whether you use the tilde here or not doesn't make a difference. It just designates this as a variable. So let's first understand what transcontour means. It is defined in the class city. So we have here the definition of direct connection, and transcontour is another relation between city and city. And there are two rules. So if there's a direct connection, then it's also a transitive connection. And yeah, if there's a direct connection from C1 to a middle city C and from C transitively to C2, then we have this transitive connection between C1 and C2. So let's go back to our query that uses this new relation transcontour. Let's tell that and ask that. That takes a few seconds, and then you see all the cities that are transitively reachable from Frankfurt. Now you may want to do it from another city like Berlin or Amsterdam. And you could do that by rephrasing the query, but a possibly better way would be to define a so-called generic query where the start city is now a parameter that you can use here. Before we had Frankfurt here, and now we have this parameter, which serves like a variable. And when you call the query, you can provide the start city here. So we can, this query is already in the database. So let's display it, reachable from, that's this one. And if we ask it here from this menu, we can select the start city here. So let's say we are interested in the cities reachable from Malmö, and we ask it, and then these are all the cities reachable from Malmö. The query also outputs Malmö here, which is the function of the so-called computed attribute category that we had in the definition of reachable from. So let's go back to this definition again. So we have this, not only it is a parameter, it's also a computed attribute. If we ask this query without giving a constant parameter, so reachable from ask, and then just leave it out, just ask it as it is, then it will compute the complete transitive closure of this query. So that's the answer. So Leningrad is reachable from all these cities. Still, we are in Leningrad. München is reachable from another large city. So it's a highly connected graph. So the transitive closure is also rather big. Good. I would like to conclude with kind of a tricky query that is a dead-end city. So a dead-end city is a city where you can either not reach another city or you can only reach dead-end cities. So all the cities that are reachable are dead-end cities. If the city has no connection, then it's automatically a dead-end city because it fulfills this constraint. Yeah, if there's nothing, then the all quantifier is fulfilled. So if we ask that, we get all the dead-end cities that either have no connection or you reach them from you have a city where you can only reach other dead-end cities. So that completes this little demonstration. I give the link to the source code in the description. Thanks a lot and see you next time.